Hey guys, Dr. J here, and in this video we're going to continue talking about airspace charts. Again, you'll be able to access some of these links in the notes to this video, but you can get more information in the PHAC and the Aeronautical Charts User Guide. Skyvector.com is the place to get online and actually look at charts and get some experience reading them. Now in this video we're going to talk about these last sections here. Navigation aids aren't necessary for UAS pilots or UAV pilots, but they can be used by manned aircraft pilots to navigate. Now, let's just go ahead and pull this up on the chart. So these are navigation aids. They're really, again, not used by UAS pilots, but they're used as navigation aids for manned pilots. And they basically look like this circle here. You see there's kind of a compass on the chart, and at the center here is a symbol. But this compass diagram is the navigation aid, and it always has this symbol in the center, or another symbol similar to that. Okay, so that's our navigation aids. And again, one thing to keep in mind is that these are not for UAV pilots, but you want to make sure not to get them confused with, for example, the Class B airspace. So Class B airspace is also going to have these blue lines. Make sure that you're not confusing this. This has these little tick marks around the outside edge. So this is not the same as Class B airspace and is not telling us anything about controlled airspace. Victor Airways or Federal Airways, these are straight line segments that go between VORs, and these act like air highways. Again, let's just jump right into the charts. So here is again one of these VORs, these navigation aids. You see there's a slightly different symbol in the center there. But emanating from the center, you've got all these light blue lines, and these are these Victor Airways. Now you'll notice that each one of these airways has a degree, a symbol saying what the orientation of that airway is. You see the name there, V14, V313, so on and so forth. And so these are just air highways. And again, not something that you need to be too concerned about as a UAV pilot, but something that you need to kind of keep in mind that manned aircraft are going to be using these airways more than just regular airspace. Here is, again, kind of another snippet from one of the charts, and you see airways around different places, and you can see they're going all the way across. Here's another VOR. Here's another VOR. You see those two different symbols there, but you see in both cases you've got the round blue circle with the compass ticks. That's your clue that those are the navigation aids, and then the airways are going between those. Variation, and I should say here magnetic variation. This is the difference between true north, geographic north, and magnetic north. So we've talked in other videos, Earth's magnetic north pole is not the same thing as its geographic north pole, at least most of the time. These are in two different locations. The magnetic north pole is, of course, based on the Earth's magnetic field, whereas the geographic north pole is based on the Earth's rotation. And so on the charts, they show what are called isogonic lines. And you see one here, this dashed magenta line, I guess. This line, and you see 1 degree west. So in for this particular line, where we have a 1 degree west variation, that's the difference between the north magnetic pole and geographic pole. And this changes across the country. Depending on where you are, it's going to be anywhere from 0 to all the way up to 20 or even 30 degrees west or east. And we've talked about these more in another video, so I won't go into that in more detail here. But this is just how they look on the charts. Now, towers and obstacles are also shown on the charts. You'll see lots and lots of these different types of obstructions, group obstructions, wind turbines, high-intensity lights. 1,000 feet and higher AGL is given by this particular symbol here. Above 200 feet and below 1,000 feet AGL is given by this symbol here. Here's an example of how this might look on a chart. Okay, so if it's in italics, it's height MSL. If it's in these parentheses, we're height above ground level. And if you see there, it's under construction. And notice guy wires may extend outward from structures. So just a general safety consideration is that there may be guy wires extending out from these towers. Oh, and I just have a note here that remember you are allowed to fly 400 feet above the top of any obstacle as long as you're in uncontrolled airspace and are within 400 feet of that obstacle. So this is really helpful for folks doing tower inspections or things like that. You have no problem going up to 400 feet above those structures as long as you're within 400 feet and you're in uncontrolled airspace. A few other symbols, you'll see this glider symbol with a letter, and the letter will tell you the kind of glider or aircraft activity that's in that area. So you can see glider operations, hang glider operations, all different sorts of activity, even unmanned aircraft activity. And this is typically going to be related to military activity, military unmanned aircraft. Parachute jumping area, this is, again, we've talked about this before, but this is going to be like a skydiving area or something like that where there's folks doing jumping with parachutes. We have a symbol for stadiums, a symbol for marine lights. Here is our visual VFR waypoint. This is like one of those symbols which is at the center of the navigation aids. We have this flag here, which we mentioned before in another video, is a visual reference point. So it's a point on the ground where we can use if we were a manned pilot, we could use that as a visual reference point. It's just going to be something that is very visible from the air. There's our isogonic line symbol, and we also have space launch activity area. So that one's pretty easy to recognize. A few other symbols on the charts that I'll point out is the power transmission line. And by the way, all of this information I'm telling you right now is available in the legend of the charts. So you can pull up a particular chart. You can do this in SkyVector. I'll show you how to do that later. And you can look at the legend, and this will have all that same information. We've got power transmission lines, aerial cables, lookout towers, mountain passes, and let's look at some examples. So let's look at this particular chart section, and I'm just going to kind of go through here briefly and point out some things for you guys to be looking at. So first of all, we got our navigation aids that we've talked about before with those little symbols in the center. You can see airports sort of scattered around the area. We've got our VOR, Federal Victor Airways, different places. We've got obstacles. Here's obstacles, these little symbols here we've mentioned before. Group obstacles, these obstacles are between 200 and 1,000 feet AGL. Looks like we don't have any taller obstacles in this chart section, but some other things that we do have, we've got, for example, high lines. So here's an example of a high line or power line that's going through the area. Actually, there's a number of these. Here's one here. I think I saw there's one there. So these ones are going all across the area. There's some. And so we've got those all over. We've got different things here. I'll point out some of the obstacles here have elevations in MSL. There's elevation MSL. And then below that in parentheses, there's the elevation in above ground level. So 254 feet, 349 feet, 276 feet. These are all elevations above ground level. Notice not all of them will have elevations above ground level, but many of them do. What else? I noticed over here we've actually got some glider activity. So here's a G for glider. Here's also another G for glider. So we've got some glider activity going on. I believe I saw somewhere here. Here we are. Here's parachute activity. So this particular airport might have skydiving or something like that, where we have parachute activity going on in the vicinity of that airport. Just one general thing to notice is that you also see highways. So for example, here's Highway 51 going through this area. Here's lakes. There'll be lakes and creeks. Here's a particular creek. So you'll see general geographic information on the charts as well. I'm sure you've already noticed that town names, city names are also on the charts. So here's Vandalia. Here's a note to say there's a prison here. So again, just all sorts of general geographic information which might be useful for pilots. This is also useful for us as UAV pilots in order to be aware of what's going on around us and keep in mind what kind of aircraft might be near us if we're near one of these VORs, for example, or if we need to watch out for obstacles or power lines or whatever. Maybe we have a flight. We can't tell exactly how far away a power line is, but we can look on the chart and see, oh, it's however far away. And we'll actually talk in just a minute about reading distances off charts and looking at latitude and longitude and things like that. And speaking of latitude and longitude, that's coming up right now. So latitude and longitude are marked on the charts by these quadrants. And I'll just back up here for a second. So here we've seen this before. We've got these quadrants marked off. And these are quadrants in latitude and longitude, not UTM, but actual latitude and longitude. So quadrants are marked by a 30-minute line. So 1 degree of latitude or longitude is 60 minutes, and 1 minute is 60 seconds. So this is the division of degrees, and the quadrants are marked by 30-minute lines. So 37 degrees, 37, 30, 38, 38, 30, so on. And each tick mark is going to be an increment of 1 minute. So if we look at our chart here now, here we've got one quadrant marked out, and let me toggle that off for a second. In this case, we've got this other line going through here. You have to be careful to get the correct line. But in this case, we've got the quadrant marked out with this blue line. And each outer part of the quadrant is going to be a 30-minute marker. So here we have 87 degrees, and we have what looks to be 37 degrees. So that's going to be this. That means this line here will be 3630. And this line here, on the vertical side, the longitude line, will be 8730 degrees west. So 87 degrees, 30 minutes west longitude. This is how our longitude and latitude is going to be marked on the charts. And then, of course, we have the individual tick marks. So I'm going to toggle that blue off again. You can see each one of these tick marks here. These are going to be worth 1 minute. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll see that there is a bigger marker at the 10-minute mark. So I've got from 36:30, I've got 10 to here. That's 36:40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 36:50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 37 degrees. So let's just look at some examples of airspace charts, and how to read these charts. All right, so here's a question for us. What are the classes of airspace starting at the ground and going up to 18,000 feet at the location of the tip of this arrow? So if we look right here, what kind of airspace do we have? Now, this is an interesting question because you can see we're in controlled airspace. We're in Class D controlled airspace. So here's Class D. The Class D marker is this dashed blue line, and that's going to be all the way to the ground. That's going to go all the way to the ground surface. Now you'll notice we've also got these solid blue lines here. That's going to be our Class B airspace from a different airport. Looks like Phoenix Airport off on the left. But right here, our controlled airspace at the ground is going to be Class D airspace. So we'll have Class D airspace from the ground to how high? It's going to be, well, we can see our airport here is at about 1,400 feet MSL. And then you see this number here. This number is the number denoting how high this controlled airspace goes above mean sea level. So this is denoting we have controlled airspace up to 3,400 feet MSL. This is 1,400 feet. That means our Class D airspace is going up to 2,000 feet AGL, above ground level. So we're starting at 1,400 feet and going up 2,000 feet above ground level, Class D airspace. Now that's as long as we're not hitting Class B airspace. So let's just take a careful look at this for a minute. Now, first of all, you see this little section here, this little sliver of airspace actually starts at 3,400, which is at the top of the Class D airspace. So we know that we're not intersecting Class B airspace below 3,400. So this is just going to be Class D airspace. So at this point, we're not in this little sliver. We're just right here. At this point, we're Class D airspace from the ground to 3,400 feet MSL. Now, what comes after that? Well, we've got this Class B airspace out here, so we should figure out where that is. If we look around, we need to find two numbers. Here's our two numbers. These two numbers are describing the bottom and the top of the controlled airspace in this Class D airspace section. So this is 4. Notice that these numbers are outside these other Class D airspaces. So there's no Class D airspace here. This number is telling us where the Class B airspace starts. It's starting at 4,000 feet MSL, and it's going up to 9,000 feet MSL. So we know right at this location, there's no other divisions showing us Class B airspace over here. So at this point, this location, we'll have Class B airspace starting at 4,000 feet and going up to 9,000 feet. Now that means that there's about 600 feet from 3,400 to 4,000 feet MSL where we're not in Class D airspace and we're not in Class B airspace. So what is the class of airspace going to be in that case? It's going to be Class E airspace. And Class E airspace is going to be starting at 3,400 feet MSL, going up to 4,000 feet MSL. Now, of course, we're in this flight path here, this airway, and that would also be Class E airspace. But since we're already in Class E airspace, we're at 3,400 feet, then it's all just going to be Class E airspace. So we're in Class E airspace from 3,400 feet MSL to 4,000 feet MSL. Then we're in Class B airspace from 4,000 feet to 9,000 feet MSL. And then we're back in Class E airspace from 9,000 feet MSL to 18,000 feet MSL, and Class A from 18,000 feet and up. So actually, this is this particular point has several layers of controlled airspace. Starts at Class D on the ground, transitions to Class E, goes back to Class B airspace, and then back to Class E, and then, of course, Class A airspace up at the top. So a little bit complicated, but should be fairly straightforward based on what we've learned so far. One thing to keep in mind is that these numbers are giving us the level or the height of the airspace where it's starting, that's the bottom number, and stopping, that's the top number. And again, thinking about it as from the ground up. So over here in this section, we've got Class B airspace starting at 2,700 feet MSL, going up to 9,000 feet. Here it's starting at 4,000 feet, going up to 9,000 feet. In this little sliver, it's starting at 3,400 feet and going up to 9,000 feet. Here's another example. We're going to take this little arrow and look at the very tip of the arrow. And again, we're in one of these airways, and we're going to figure out what is the airspace at that arrow point. So you'll notice this is our airspace here where we just were, the Falcon Field airport. Now we're up just a little bit of ways from there. So first of all, do we have any controlled airspace at the ground? We see our solid lines, that's Class B, but there's no airspace going to the ground. We see our numbers here, starting at 5,000, going to 9,000, here starting at 7,000, going to 9,000. No controlled airspace as far as the Class B airspace is concerned at the ground here. What else do we have? Well, we've got this airway, V190 is our airway here. So that means we're going to have, at the very least, we'll have Class E airspace starting at 1,200 feet and going up to 5,000 feet. Why 5,000 feet? Because that's where Class B airspace starts. So I don't see any other indications that we have controlled airspace at the ground. So that means at the ground, right here at this location, we've got Class G airspace from the ground to 1,200 feet MSL. We've got Class E airspace in this airway, starting at 1,200 feet, going up to 5,000 feet, where we hit the Class B airspace. Then we have Class B airspace up to 9,000 feet MSL. And then finally, we've got Class E airspace again from 9,000 feet to 18,000 feet. And then Class A from 18,000 feet on up. So again, we have kind of a layered structure where we have Class G, then Class E, then Class B, then Class E again, and then Class A. So you've got to watch for these numbers. That'll tell you the heights of when those airspaces start and stop. In some cases, they'll be going all the way to the surface. In cases like this, where we're getting out away from the airport, they'll be stopping some elevation above the surface. Now, a few other things I'll point out on this chart before we move on is that you see again, here's our variation line. There's that very magnetic variation line, and this time it's 10 degrees east. So we're 10 degrees, our magnetic north is 10 degrees east of true north. We've got a couple of wilderness areas here. We've got some bald eagle breeding areas, which are no-fly zones. So if we were to put our arrow, let's say here we cannot fly as UAV pilots because we're in this restricted wilderness area zone. Now, these zones, I think, if I remember correctly, go up to 3,000 feet typically. So if we were a manned aircraft pilot, we could fly above these without a problem once we're above 3,000 feet. Obviously, as UAV pilots, we are not allowed to go over 400 feet without a waiver, and so we would not be able to fly in this area at all. All right, so that's the last slide I think I have for charts. The best thing for you to do is to get a look at skyvector.com and just start getting some practice with looking at charts, reading the charts, seeing what different areas look like. Look at your areas, the areas where you'll be flying on the skyvector.com charts. Look at the legends and just get used to looking at these charts. And again, the more time you spend looking at the charts, the better you're going to do on the Part 107 exam.